Hi, my name is Jared. I'm the founder of Achiever's Dream. So today, I'm going to share with you how can you learn O-level chemistry electrolysis secondary 4 easily. Okay, because a lot of my students have struggled learning this, so I decided to come up with a video for them. And in this very short video, my aim is to finish it within 15 minutes. You will get to learn the whole of electrolysis. Okay, so right now, the outline of today's presentation, today's sharing, is that first, the background knowledge. Second, the explaining of drawings. Third, inner electrodes. Usually people use carbon or platinum. Let me add it in. Platinum. You can write it down in your notes. Platinum. Okay. And last one, the reactive electrode that we use is copper. Okay. So the background knowledge that we need. Okay. The background knowledge is redox. Okay. Why redox? Because in this very component, okay, but before I continue, for students who have forgotten what's redox, it mainly revolves around oxidation and reduction. Okay, number one, we're looking at oxygen, okay, hydrogen, oxidation state, and electrons. Increase in oxygen is oxidation, decrease in hydrogen is oxidation, increase in oxidation state, decrease in electrons, and the opposite for the rest. Okay, so but in this instance, right, what's important for electrolysis that we are focusing on is electrons, is this thing over here. So once you can get these premises correct, we are ready to build on what we already know in what we can know. Okay, so the first example that we have, okay, example one, okay, we are using, okay, first let's start with an electric cell. Okay, electric cell. Okay, a battery cell. Okay, battery cell. So this is the short one is the negative sign, long one is a positive sign. Okay, the one that's connected to the positive sign. Okay, this is called an electrode. E-L-E-C-T-R-O-D-E. There's two kinds of electrode. One is called inert, one is called reactive. Okay, but the one that is connected to it is called anode. Okay, so how I usually teach this topic is that anode, right, usually oxidation occurs over here. So for oxidation to occur, just now we learned that they have to lose electrons. Okay, so right now, how about this side? The negative side, it is connected, okay, to this thing called cathode, okay, whereby it is an increase of electrons lead to reduction. Okay, once you see this happening, you can understand this. It is a very good start. Okay, so example one. Okay, example one, we are gonna put everything in, okay, into what we call an electrolyte, a place for the ions to move. Okay, so one of the electrolytes that I'm going to use, for example, one is NaCl, which is molten. Okay, molten. So students often ask me, hey Jared, what is molten? Okay, liquid. Okay, what is this? What's the difference between liquid and aqueous for the state symbols? Okay, what I explain to them is that imagine a bowl of soup. Okay, if let's say it is very salty, okay, because there are very little water inside, it is liquid, it's concentrated. If let's say it is aqueous, it is very diluted, a lot of water inside, it is called aqueous. Okay, so think if it's easier for you to remember. Okay, so over here, I always teach this 4-step process to my students to learn electrolysis. Number one, ions present. Okay, number two, half equations at where? At cathode and anode. Okay. Number three, the observations over there. Okay, the observations that we observe. Number four, it is, okay, the full equations. Okay, so the first question I'm going to take up some time. Okay, but subsequently I'm going to move faster and faster. Okay, so what happened at anode? let's start from the ions present. Step 1, ions present. Okay, number 1 we have Na plus, okay, molten. Next we have Cl minus molten. That's it. Okay, so from here what do? Okay, what we do is this. Okay, we write anode over here. Okay, anode. So anode, right? Imagine this, there are a lot of Na plus and Cl minus in this whole electrolyte like solution over here. But because anode being positive, right, it will attract all the negative ions. Okay, Na plus being positive will attract all the, okay, cathode being negative will attract all the Na plus ions, okay, all the positive ions. So at anode, right, Cl minus will be there. Okay, Cl minus, okay, have to lose electrons because it is anode. We have to lose electrons. We lose electrons to give you Cl. But wait a minute, we can't think about it. Cl is actually a diatomic molecule. Why is a diatomic molecule? Okay, so there are some videos that I'm going to create in future that will allow you to understand, but in general it's just in a pair. So Cl exists as in a pair is 2, so it's 2E minus and 2Cl minus. Okay, please put in the state symbol as this is very important. So, but in electrolysis, we do not want to see the negative sign. Okay, so what we're going to do is just like math, we're going to bring it to the right hand side. Okay, we're going to bring it this side. Okay, so which is 2Cl minus gives you Cl2 gas plus 2E minus. Okay, so the observation you can describe about the greenish, yellowish green gas that's observed at anode. Okay, so how about cathode? Cathode. So what happened is that Na plus will be there. Na plus at cathode, they have to gain electrons. Since they have to gain electrons, what's going to happen is that you will get to see Na, which is sodium. Okay, sodium, a solid will be deposited, okay, around cathode. That's it. So once you see this equation, you tell me the observation of this, which is yellowish green gas observed. Over here, gray metal is observed, is deposited at cathode. Okay, so we done with this point, observations. Let's go to doing of the full equations. Okay, once I explain to you and you see how I derive it, it is very easy for you to understand how to do this. Okay, so first I write down what's on the left and what's the right. Okay, what do I mean by that? This is the left hand side, this is the right hand side. This is the left hand side, this is the right hand side. Okay, what's on the left? Na plus, E minus. Okay, plus. Okay, plus 2Cl minus. Molten. To give you Cl2 gas plus 2E minus plus Na. Okay, so sorry. Alright, so from here, right, what you do is that you take a look. Hey, you need to balance the electrons. So to balance the electrons, I realize that there's 2 here, so there needs to be 2 over here too. So I times 2 throughout. Times 2, times 2, times 2. Okay, so there's 2 here, 2 here, and 2 here. At this point of time, I can cancel the electrons. So this will be your full equation, which is Na plus, okay, 2 Na plus, liquid plus 2Cl minus liquid gives you Cl2 gas plus 2 Na solid. Okay, this is example 1 using NaCl liquid. Okay, so right now I'm going to pause here for a while. Okay, pause here. Okay, so in example 2, okay, example 1 we are done, but now I'm going to example 2. We are going to explain using NaCl aqueous. Okay, just now we use NaCl molten. Okay, right now I'm going to use NaCl aqueous. Okay, so likewise, we're going to do the 4 step. I'm not going to draw the diagram anymore. So number 1 is the ions present. Okay, you get used to it. Is you have Na plus, sorry. Okay, Na plus. Okay, you have AQ. plus Cl minus Aq, but this time around, because it's aqueous, there's water inside, there's water content inside, so we put H plus and OH minus ions in there. Okay, so both of this, okay, will go towards the cathode. Why? Because cathode is connected to the negative terminal. Okay, terminal. Okay, it's connected to the negative terminal, while, okay, the anode is connected to the positive terminal. The positive terminal, that's why you attract negative ions. Okay, so what will happen at, what will happen at cathode? At cathode, okay, Na plus and H plus will move towards there. So you'll be thinking, hey, so who gets discharged? So I'll let you bring to your attention back to reactivity series, whereby there's this thing called please stop calling me a zebra. All the way you see hydrogen here. Okay, sodium is at the top, where hydrogen is at the bottom. So who do you think get displaced easier? Is it sodium or hydrogen? Okay, so as you know, of course, hydrogen being less reactive will get discharge. Okay, so H plus comes here, plus E minus become H, but hydrogen exists in the pair diatomic molecule. There's 2 over here. Okay, so it's AQ is gas. So observation will be, you talk about the bubbles of gas as observed, which is H2. Okay, at anode, what happened? At anode, okay, you have Cl minus and OH minus. Okay, Cl minus and OH minus will go to anode, and who get discharged? Over here, there's a table for us to follow. There's nitrate, sulfate, okay, followed by the reactivity series of group 7, fluorine, chlorine, bromine, iodine, OH minus. Okay, so who get discharged easiest? The bottom. Okay, this is the most difficult. This is the easiest. Okay, so OH minus at anode get discharged. Okay, so what you have is OH minus. This is a formula that you have to learn. Okay, 4OH minus give you 2H2O liquid plus O2 gas. It gives you 4 plus 4E minus. You talk about the oxygen that's released over here. Okay, so right now you can see that H plus ions displaced, OH minus is also displaced. Okay, so what we will observe, number 1 is gas bubbles release here, the bubbles is released here. Okay, so finally, how do I combine both together into one full equation? I times 2 here, 4, 4, 2, because there's 4 electrons over here. So I combine what's on the left and what's on the right, which is 4H plus, okay, AQ, plus 4E minus, plus 4OH minus AQ, gives you 2H2 gas, plus 2H2O liquid plus O2 gas, plus 4E minus. So at this instance, I'll cancel this. This will be your full equation. Alright, so the final equation, after you cancelling, you get 4H plus, 4OH minus, 2H2O plus O2 from 2H2 after you combine the left hand side, which is from here and here, and combine the right hand side. Here is the left, here is the right. Okay, so I'm going to move on to the take example, which is the last example to teach electrolysis. It's NaCl aqueous, but this time around is concentrated. Okay, so concentrated, right, affects only the halide ions. Okay, why do I say this? Okay, let me explain. So here you have Na plus, here you have H plus ions, the ions present. Step 1, the ions present. Cl minus OH minus. So in this instance, who will get discharged? Okay, so H plus get discharged. Okay, and this H plus gets discharged at cathode, whereas anode, who get discharged? Okay, anode, right, Cl minus, instead of OH minus get discharged, right, according to the table I drew just now, Cl minus will get discharged because there are a lot of them. There are a lot of them because it's concentrated. So in this instance, Cl minus get discharged. This is just a small difference, so please do take a note. Okay, so what happened next? So from here, right, what you have to know is, number one, ions present. Number two, the half equations for both, which I've done it just now. Let me quickly write it for you. Plus 2E minus give you H2. Alright, this is Cl minus gives you Cl2 plus 2E minus. Alright. So I will learn that if, let's say, electrons is on the left hand side, this is a reduction reaction. If electrons on the right hand side, it is an oxidation reaction. Okay, because just now I've explained all the electrons come from the left hand side, but because it's negative, you lose electrons, your oxidation, you move them to the right hand side. Okay, so right now, to summarize what I've thought so far, okay, but before I summarize, sorry, okay, if let's say you get H plus ions discharged, right, okay, imagine in the solution there's H plus ion and OH minus ions. Okay, if H plus ions get discharged, you're only left with OH minus is inside, so the solution will become more alkaline. Okay, but if let's say right now OH minus is discharged, okay, OH minus is discharged, leaving H plus inside, you become more acidic. Okay, it's alkaline. Okay, if H plus and OH minus both get discharged, what happened? Concentration, okay, will increase. Alright, if let's say both H plus and OH minus remains in the solution, concentration decrease because there's more water. Okay, so far so good. Okay, you have understand what is the three examples. Okay, once you understand these three examples, all these are for inert examples. Okay, let me do a very quick summary for you. Okay, before I go to example 4. Summary. Okay, summary. Okay, so we have used 3 different examples: Cl, okay, molten, NaCl, aqueous, NaCl, okay, aqueous, but this time it's concentrated. Okay, so ions present. Okay, let me quickly run through all of them: Na plus, Cl minus. Okay, so quickly run through the ions present: Na plus, Cl minus, Na plus, H plus, OH minus, da 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 da. Okay, so right now, what happened at the cathode? Who gets discharged? Okay, over here, positive will go to the negative. Okay, so Na plus becomes here, comes here. Alright, so between Na plus and H plus comes here, H plus comes here. Okay, whereas for the anode, okay, positive, Cl minus comes here. Okay, whereas at anode, OH minus get discharged. The term we use called selectively discharged. Okay, selectively discharged. Okay. Okay, and lastly, Cl minus get discharged over here. This is all for the cases of inert electrodes. Okay, so after that, right, I'm going to explain using reactive electrode. Okay, back then all you have seen, right, is the electrode do not mess around, but this time around I'm going to show you examples whereby they mess around and what's going to happen. Okay, so right now we're going to talk about copper electrode. Okay, electrode. Okay, so for example, just now we have talking about carbon electrode, but right now we're talking about copper electrode. What's the difference? This is not carbon anymore. We're going to change it to copper. Okay, so what happens right now is copper being an unreactive metal. Okay, it is a reactive electrode because it is an unreactive metal. It is easier to get discharged. Let me repeat one more time. copper being an unreactive metal serves as a reactive electrode in these instances because they are easily discharged, so they will mess around with the equation, with the reaction. Okay, so for example, if your reaction CuSO4AQ with copper electrodes, what happened? Okay, give me a minute. Okay, so let me use a easier example. Let's do NaCl first. Okay, so ions present is Na plus, H plus, SO4 2 minus, Cl minus, OH minus. Okay, so over here what happened, right, is you realize that this is what going to happen at cathode. This is what happened at anode. Okay, so over here, right, just know that in cathode, okay, this reactive electrode will not have any reaction to it. Okay, because in cathode you have to accept electrons. Make sense? But copper being a metal cannot accept electrons because you cannot form Cu minus. Okay, there's no such thing. Okay, there's only such thing as Cu2 plus. Metal can only form cation ions, they cannot form anions. Cation ions is positive ions, okay? Anions is negative ions. Okay, so right now over here what happened is you apply a selective discharge, H plus get discharged. At anode, right, what happened? Okay, anode you're supposed to lose electrons, okay, but instead of chlorine or hydrogen, copper lose electrons. Copper metal reacted. Okay, that's why it dissolved. Okay, that's why it dissolved. Okay, so what happened is at cathode you will see H plus plus E minus give you H2. Okay, you explain with the bubbles of gas. Okay, whereas at anode, okay, at anode we talk about copper. Copper lose electron to give you Cu2 plus. Okay, so Cu give you Cu2 plus plus 2E minus. Okay, this is the part you have to take note. This is the difference. The change in anode. Okay. Alright, this example 4. And I pretty much let you know electrolysis through 4 different examples. The last thing you have to know, okay, okay, in electrolysis is just plating, okay, electroplating, okay, as well as purification of metal. Okay, so from here to know electroplating, you are trying to plate a metal into an equipment. Okay, we are using the fundamentals that we learned just now to do this. Okay, so for example, I want to plate a silver onto a spoon. Okay, so right now, make a guess. Okay, make a guess. Where should I place the silver? Where should I place the spoon? Okay, just now we mentioned that anode becomes smaller, right? Remember? Okay, anode becomes smaller. Okay, and cathode increase in size. Okay, why does that happen? I'm going to explain to you and how can we do the same thing, okay? So right now, we're going to put silver over here. Okay, I'm going to put the spoon over here. And we're going to use something called silver nitrate. Must be something related to silver in order to plate it, okay? So aqueous. So right now, over here at anode, okay, we know that silver will get discharged even though there is NO3 minus, OH minus, but it is easier to discharge silver. So silver got discharged. Ag become Ag plus plus Cl minus. Okay, Ag got discharged. So when this Ag plus comes here, okay, plus the Ag plus in the solution, okay, it will encourage, okay, over here, the ions present Ag plus, H plus, okay, it will encourage, okay, Ag plus in the solution to be discharged onto the spoon, which is Ag plus E minus give you Ag. Okay, so this is how the whole process works. Okay, so you will see silver becomes smaller over here and it becomes bigger over here. Likewise, if let's say we do purification, we're going to put the impure metal here. Okay, impure metal over here, the pure metal over here, where it is being coated on. Okay, so with this, we have pretty much come to the end. Okay, we come to the end of electrolysis. I've covered about inert electrode. Okay, I've covered inert electrode with 3 different examples: NaCl molten, NaCl aqueous, NaCl concentrated. Okay, these 3 examples, and I covered a reactive electrode with one use, which is with one example, which is NaCl as well. Okay, Q. And lastly, we ended off with 2 applications, which is electroplating, okay, and purification of metal. Okay, so this marks the end of electrolysis, and only through practice you will be able to learn it even better. Okay, I hope my explanations you get to understand them. If you do need extra help, let me know. Okay, contact 96964881 for more information. Okay, so with that, thank you very much. I hope you enjoyed the video. Give me some comments or things that you want to learn. Comment it so that my next video can be on that. Alright, thank you.